Alright guys, so tonight you're going to continue to work on finding inverses algebraically. Um, so let's go ahead and try this together. The question says, what is the equation form when the line is reflected over y equals x? So if you reflect something over the line y equals x, what it means is that you're finding the inverse value of the function and you're switching the x and y value and finding the what the inverse function would be. So in this case, in class we talked about using please excuse my dear Aunt Sally to help us figure out how to do this math to find the inverses. So here we're going to find out what's going down first, and then we find what's going up. So first we look and see if there's any parentheses. No, there's not any. Is there an exponent? Yes. So we're going to say squared is there. And then we look, is there any multiplication or division? Here we are multiplying by 3. And then we look and see, is there any adding or subtracting going on? And here we're adding 1. And all of this is being done to the value, well, all of this is being done. All right, so here we go and we find the opposite operation. What's the inverse of something squared? It means to take the square root. Square root. And then we go and look, and I'm going to just put dots by these. The inverse of multiplication is division. So here we're going to say divide 3. And the inverse of addition is subtraction. We're going to say subtract 1. So now we're going to start from the bottom and go up to get the inverse. So the inverse of this function, which this is the inverse symbol, or you can write the inverse symbol as y -1, but for the sake of consistency, well, I'm going to show you to write it this way. We're going to do it as f of -1. That's the inverse. Equals, and you'll see this one in math classes as well. Why? Anytime you put a -1 on something, it means inverse. So here, we're going to always write, the x value. So we're going to write x, and then from x, we're going to subtract 1. And then we're going to divide everything that we wrote by 3. And then we're going to take the square root of it all. Okay? And that would be our inverse. Now, this next question over here says, prove that the functions are inverses. So we have our original function, which is y equals 3x squared plus 1. Or we can write that as the same as f of x equals 3x squared plus 1. And the inverse of it is equal to the square root of x minus 1 over 3. And in this case, it would be, yeah, so that's the inverse of it. There's some deeper things that you need to know about this, but we'll just deal with this knowledge here. We're just focusing on how to algebraically find inverses. So now what we would do from here is we need to verify that these are inverses. So we need to do the composition of functions. So we need to decide, when I do f of g of x, does it equals x? And when I do g of f of x, does that equal x? And if both of those are the same, they both equal x, then we know that these functions really are inverses. So we're proving that they are inverses. And all right, so what I'm going to do, what this tells me is to hold the f function. So I'm going to say hold the f function, and everywhere there's an x in the f function, we're going to put in the g function. So let me show you what that means. So for this first one, I'm going to do 3, and then there's an x squared there. So instead of writing x squared, I'm going to write what the g function is, which is this inverse function. And let me write that. Well, yeah, I'm going to leave it like that. The g function represents the inverse function. So let me write this up here. G of x is the same thing as f. It's They equal the same thing. So this is my g function. So instead of putting x, I'm going to put this function in. So I'm going to put in square root x minus 1 over 3. Close that. Then I get squared plus 1. So now I'm going to do the math here, and what it tells me is when I do the math, does this equal x? So when I look at this, then I see that. So when I look at this, I notice that there's a square right here, and there's a square root. So I can rewrite this as the square root and the squared will go away. So I'm left with 3 times x minus 1 over 3 plus 1. And there's a couple of ways we can do the next thing. Since this is a 3 at the top and a 3 at the bottom, these two go away. And we get x minus 1 plus 1. And then here, x minus 1 plus 1 gives me x. So that's one side that I tested out. And now I have to go test out the other side because both have to equal x. So I found that this one equals x, so that tells me I can keep going. So I'm going to go to the inverse function, which is represented by g, and I'm going to write it. And everywhere there's an x, I'm going to put the f function in instead, because that's what this is telling me. Everywhere where the x is at, I'm putting the f function in there instead. Okay, so where this x is at, then I'm going to put 3, and I'm going to put it in parentheses, 3x squared plus 1, close the parentheses, and then I'm going to continue to write the rest of the problem. Minus 1 over 3. And that square root is over the 3 as well. Okay. So let me fix that. Alrighty, so I'm going to do the math on the inside of the square root. So what I'm going to do is divide everything by 3 that's under the square root. So I'm going to say 3x squared over 3 plus 1/3 over 3 minus 1/3. Okay? And what we notice here is, and all I did was divide each piece by 3. So we get here, if we do the math, 3x squared over 3. That makes the 3 go away here. And then plus 1/3 minus 1/3 goes away. So we're left with the square root of x squared. And remember, if you see a square root and the x squared together, then the answer is just x because they're inverses of each other. So we just proved that these two functions are inverses. We found the inverse and we proved that they were inverses. Okay, so let's go try another one. The next one says, what is the equation form when the line is reflected over y equals x? So that's the same thing as finding the inverse. So we're going to use our, please excuse my dear Aunt Sally still. And we're going to find out what's going down first and find out what's going up next. Okay, so first we want to look for parentheses. This time we have some parentheses, so we have to say what's going on in those parentheses. So we go through, please excuse my dear Aunt Sally, for the parentheses. So is there any are there parentheses inside of the parentheses? No. Is there an exponent inside the parentheses? No. Is there multiplying or dividing inside parentheses? No. But there is an adding and subtracted inside the parentheses. So we're going to say add 4. Now next, since we've done all of this for the inside of the parentheses, I'm going to go to the next part of the question now. Now, is there an exponent? Yes, and we're going to say it's a square. And now Do we have any multiplication or division? We're going to say this 3 is being multiplied by x plus 4 all squared. So we're going to say multiply 3. And then is there any adding or subtracting going on? We're going to say add 1. Okay? So now I'm going to go and do the opposite of those. Sub 4, square root, divide 3, subtract 1. And now I'm going to do my inverse symbol, f of -1. And you can say y -1, same thing. I'm going to write my x and I get my inverse from this side. The inverse comes from, and I'm going to highlight that, it comes from this side. So we always write down x, and then we're going to say subtract 1, divide 3, take the square root, and then subtract 4. And then we're done with finding our inverse. And I'm doing it in my head right now to make sure I'm good. Yep, I'm straight. All right, so now it's telling me to prove that these two functions are inverses. So in order to prove that they're inverses, we have to do f of g of x. We have to take the composition, or we have to find the composition of both of these functions. Does that equals x? And if I do g of f of x, does that equals x? Which is the same thing as saying f of the inverse function. And I just called it g. But let me just do that. And I'm calling the inverse function g function, so I don't have to keep writing that -1 up there. So this is the same thing as g of x. Okay? And do they both equal x? If when I do the math, they both equal x, then I'm sure that they're inverses, and I proved my point. So here it tells me to hold the f function. The f function is the same thing, and y is the same thing as f of x. Okay? So the f function is 3, and it tells me everywhere there's an x, put in the g function. So here's my g function down here, and so I'm going to put in square root of x minus 1 over 3 minus 4. Oh boy, hold on, I need more space, guys. Let me write a little bit smaller because I had a lot to put in. Okay, so I keep the 3, and I'm going to go write parentheses, and I'm putting in the square root of x minus 1 over 3 minus 4 plus 4 squared plus 1. All right, so now I'm going to go through and do the math. So 3x square root of x minus 1 over 3, -4 plus 4 is 0, so that goes away, and squared plus 1. And here, the square root cancels out because of the squared, so we're left with x minus 1 over 3 plus 1. And then here, the 3's cancel out. We end up with x minus 1 plus 1, and we just get x. So we proved it for f of g of x. Now it has to work for both. You have to check it for both. And if both works out, then you know you got yourself an inverse function. These two functions are inverses of each other because they both should equal x at the end. So here I'm going to hold the g function, which is the same as the inverse function, and I'm going to go ahead and put in the square root symbol. And everywhere there's an x, I'm going to put in 3x plus 4 squared plus 1. Okay, and then minus 1 was already there over 3. And then the minus 4 goes on the outside. So I'm going to go through here and do the math. So I'm going to give the 3 to each part of the equation. So I'm going to say 3 over x plus 4 squared over 3. Oh, you know what? I could simplify this because, you know, I'm going to go ahead and simplify this. Oh, you could do it either way. I'll keep it consistent. Plus 1 over 3 minus 1 over 3 minus 4. So I divided each part by 3. So this and this goes away. The 3 on the top and on the bottom reduces to 1. And plus 1/3 minus 1/3 is 0. And then we get minus 4 on the outside. Inverse, when you see the square root and the square, they're inverse operations, so they reduce each other down to 1. So we get this that's left, and we have the answer is equal to x. So we can say, yes, they are inverses because g of f, well, let me do it the other way. Because f of g of x and the composition of g of f of x both equal, they both equal x. All right, and we know they're inverses because we just proved it, because they both equal x. All right, one more, and then you guys go ahead and do your practice. So it's the same question. What's the equation formed when the line is reflected over y equals x? So I'm going to find that is the same thing as finding the inverse. So here, then we're going to use please excuse my dear Aunt Sally. So do we have some parentheses? Yes, and then you go through the process inside the parentheses. Do I see any parentheses in the parentheses? Do I see an exponent inside the parentheses? That's a no to both of those. Is there some multiplying or dividing inside the parentheses? No. Is there some adding and subtracting inside the parentheses? Yes, and that's a add 4. All right, so we took care of the parentheses part, and now we need to go to the exponent part. We're going to say we have cubed out there. Do we see any multiplication? Yep, this 3 is being multiplied by x plus 4 raised to the cube power. So we're going to say multiply 3. And then do we see any adding or subtracting going on? And yes, we do. That's an add 1. Now I want to do the inverse. So I'm going to say subtract 4. And we're going to say cube root divide 3 sub 1. So the inverse of this would be equal to, we always write x and we start from the bottom and go up, minus 1 divide 3. Cube root is written like this, and make sure you put the 3 on it, and then subtract 4. And then from there, it says prove that these functions are inverses. So I'm going to say, I'm going to call y f of x, and I'm going to call the inverse function g of x, so that I can just have a simplified version. Okay, so in order for these to be inverses, we have to say that the composition of f of g of x has to equal x, and the composition of g of f of x has to also equal x. If they both equal x, then you're good. If one doesn't equal, it's no use in trying the other one because it doesn't work. It's not going to work. All right, so I'm going to hold the f function, which is 3, and then wherever the x is at, I'm going to put in the g function. So cube root of x minus 1 over 4, x minus 1, 3, and then minus, hold on, I need to write smaller, just a second. So 3, and then parentheses, x minus 1 over 3, and that's to the cubed root. Minus 4 plus 4, and all of that's cubed plus 1. Alright, so this was what I put in for x right here. This is the part for x. And now I need to go in and do the math. So 3 times the cube root of x minus 1 over 3. Negative 4 plus 4 is 0. So we just get this plus 1. Cube root and something cubed makes that go away. So we're left with 3x minus 1 over 3. Oh, not 3x, sorry. Just x minus 1. And then plus 1. Okay, so the 3's go away and we get x minus 1 plus 1, and we get x on the left side. So now I have to go test it for the right side as well. So it tells me to hold the inverse function, which is g. So I'm going to go here and do wherever there's an x, then I'm going to put in the y function or the f of x function. So 3x plus 4 cubed plus 1. And then I put the minus 1 back there over 3 minus 4. Okay, I'm going to go in and do the math. So here, I'm going to go ahead and just divide everything by 3. So I get 3 divided into 3, and this x plus 4 cubed is all one quantity together. Wait a minute. Let me write that a little neater. So we get 3x plus 4 cubed, that's one quantity together, over 3 plus 1/3 minus 1/3 minus 4. Alright, this goes away. Cube root of x plus 4 to the cube, that goes away, minus 4. And then we're left with the cube root, and the cube reduces to 1. So we get that. And then plus 4 minus 4 is x. And so since both equals x, you can write, we've proven the functions are inverses because because f of g of x, oh wow, hold on. I got a new slate, y'all, so I'm testing it out. Because f of g of x and g of f of x both equal x. Okay? And we're done. Alright, so it's your job to try the next 3 problems out and put them in your book creator. And I'll see you guys in class.